For the last 100 years, basically every textbook, every telescope, and like every theoretical physicist has told you the exact same thing.
Right.
They say the cosmos is stretching. You know, you've heard the analogy 1,000 times. It's a balloon blowing up, and the galaxies are just like dots drawn on the rubber, right? Stretching further and further apart.
Yeah, the classic balloon analogy.
Exactly. But what if they are all fundamentally misreading the data?
I mean, it sounds like absolute heresy, honestly.
Oh, totally.
Especially considering the sheer amount of infrastructure built around that model.
Yeah.
But when you look at the observational crises piling up in cosmology right now, heresy might be exactly what the field requires.
And that is exactly our mission for this deep dive. Today, we are taking an absolute sledgehammer to the past century of physics.
We really are.
We're looking at a framework called mode identity theory, or MIT,
Right.
and we are going to unravel why the universe has the specific particles, forces, and constants it does purely by looking at its shape.
Yeah, the literal geometry.
Right. But before we get into the mechanics of this, I need to lay down a strict ground rule for you, the listener. If you want to engage with this framework, you have to completely discard the concept of a stretching cosmos.
Right. You have to let it go entirely.
Space is a static, finite three-sphere, period. It is not stretching.
Which means, we immediately have to confront redshift.
Right, because that's the elephant in the room. Edwin Hubble observed that light from distant galaxies stretches to the red end of the spectrum.
Exactly. And standard cosmology interprets that as physical movement, right?
Yes.
The galaxies are supposedly receding.
But MIT changes that.
Completely. Mode identity theory proposes that redshift is simply phase evolution on a cosmic standing wave.
So the space isn't moving.
No, not at all. The observer's position on the wave is advancing. The universe is perfectly static.
Wow. Okay, so we're dealing with a paradigm that flips the script entirely. And to understand how someone arrives at a framework this radical, we kind of have to travel back to ancient Greece.
Yeah, we need to look at Plato.
Right, Plato's philosophy of form before function.
Exactly. Plato argued that topology and geometric shape exist logically prior to any matter or dynamics.
Meaning the geometry comes first.
Right. The geometry of a space dictates the physics of what happens inside it, not the other way around.
That makes sense.
Think about the acoustic properties of a cathedral.
Yeah.
Right? The shape of the stone walls, the arches, the vaulted ceilings.
They shape the sound.
Exactly. Those geometric structures dictate how sound will bounce and resonate long before a choir ever sings a single note.
Oh, I love that analogy.
Yeah, and mode identity theory takes that concept and applies it to the fundamental fabric of reality. The geometry of the universe was established, and the waves flowing through it just had to conform to that shape.
So matter is just a consequence of those waves conforming to the geometry.
Right, form before function.
That brings us to the architect behind this theory. Because, you don't just wake up one morning, stretch, and casually decide to rewrite general relativity in the standard model.
No, you definitely do not.
The author of this framework has a background that is incredibly unconventional for theoretical physics.
Very unconventional. The author actually grew up in a demolition company.
Literally tearing structures apart.
Yes, tearing things down to see how they were put together. And eventually, they became a civil engineer, specializing in forensic structural engineering.
Forensic structural engineering. So for you listening, this is the science of looking at a catastrophic failure, like a collapsed building or a collapsed bridge, and working backward.
You don't look at the superficial damage.
Exactly. You look for the exact load-bearing beam that snapped first. You map the load paths.
And that's the key. Forensic engineers have a fundamentally different relationship with math than theoretical physicists do.
How so?
Well, in modern physics, if an equation diverges to infinity or, doesn't match observation, the trend is to just invent a new mathematical patch.
Like adding dark matter.
Right. You add dark matter, you add dark energy.
Yeah.
You just invent a new invisible field.
But a forensic engineer wouldn't do that.
Exactly. A forensic engineer looks at a failing model and says, the foundation is cracked. Let's strip it down to the studs.
You don't add more paint to a condemned building.
You really don't. And mode identity theory is basically a forensic teardown of 20th century physics.
Okay, so if we are stripping the universe down to the studs, what do those studs actually look like? Like, what is the core geometric postulate we are working with here?
The foundation is purely topological. The universe is modeled as a Mobius band embedded inside a static three-sphere.
which in math is denoted as S3, right?
Yes, exactly. S3.
I want to make sure we visualize this correctly because when people hear three-sphere, they usually picture a regular sphere, like a bowling ball.
Right, which is a two-sphere.
Yeah, a regular 3D globe has a 2D surface. You can only move north, south, or east-west. But a three-sphere is a higher dimensional space.
It is.
The surface itself is three-dimensional. So if you fly a spaceship in any straight line, you will eventually wrap around the universe and hit the back of your own head.
That's a perfect way to describe the ambient S3 geometry. But the crucial structural component is the Möbius band embedded inside it.
Right, the Möbius band.
Yeah, it's a non-orientable surface. So if you take a strip of paper, give it a half twist, and tape the ends together
You create a surface with only one continuous side.
on one continuous edge.
Okay, but what does that twist actually do to the physics of the universe?
It forces an anti-periodic boundary condition on any wave traveling through that space.
Anti-periodic boundary condition. Break that down for me.
Sure. Because the surface is non-orientable, a wave completing one full lap around the Möbius strip picks up a sign flip.
A sign flip. So if the wave starts at a positive peak...
It returns as a negative trough.
Oh, wow.
Yeah. So it actually requires 2 full laps, a 4-pi rotation, or 720 degrees just to return to its original positive state.
Wait, hold on. A 720-degree rotation to return to normal?
Yep.
That is the exact defining characteristic of fermions.
Exactly.
Like, for you listening, the particles that make up all the matter in the universe, electrons, quarks, protons, they all have half-integer spin. In quantum mechanics, you literally have to rotate an electron 720 degrees for its wave function to return to its original state.
Right. And for almost a century, half-integer spin was treated as this isolated, slightly bizarre quantum rule.
Yeah, it was just math. Paul Dirac discovered it mathematically.
But physics never provided a structural reason for why matter behaves this way.
Until now.
Exactly. Mode identity theory provides the actual mechanism. Matter is fermionic because the physical field is coupling to the non-orientable structure of the universe's geometry.
The topological twist is literally built into the room.
Yes, and the particles are just the sound waves forced to echo through it.
Form before function, the geometry forces the physics. That makes total logical sense. But I have a major objection here.
Let's hear it.
And I'm sure anyone listening who has taken an astronomy class is screaming the exact same thing. I know the Doppler effect.
Right.
I know what happens to a police siren when it speeds away from me. The sound waves stretch and the pitch drops.
The standard redshift argument.
Exactly. When we look at distant galaxies, their light waves are stretched. They are redshifted. So if this universe is a static three-sphere and those galaxies are not physically moving away from us, how is a static standing wave tricking every telescope on Earth into seeing them stretch out?
To answer that, we have to look at the temporal edge of this geometry. The framework introduces a cosmic standing wave.
Okay.
And it's defined very simply by the equation cosine of θ over 2.
A standing wave. So instead of a wave crashing onto a beach, think of a guitar string.
Right.
You pluck it, the string vibrates up and down, but the string itself doesn't travel across the room. The wave is stationary.
Correct. Now introduce a local observer. As time passes, the observer's phase position on that standing wave advances.
Yeah.
MIT calls this the waltz clock.
The waltz clock.
Yeah. Redshift is not a measure of velocity. It is a measure of phase differential.
Oh, I see.
When a telescope captures light from a galaxy billions of light years away, it is sampling light emitted at a previous phase position on the standing wave.
So the redshift is just the fractional difference between the phase of the wave when the light was emitted and the phase of the wave when our telescope receives it.
Exactly.
The wave is oscillating, our clock is ticking, and the difference between the two looks exactly like physical stretching.
It perfectly mimics the kinematics of a receding object. And this forces a complete reevaluation of Albert Einstein's history.
Specifically, his history with the cosmological constant, right?
Denoted by the symbol lambda.
The famous biggest blunder. Let's establish the history here for context. In 1917, Einstein applies his brand new equations of general relativity to the entire universe.
Right.
And he realizes gravity should cause all the mass in the universe to pull itself together and collapse.
So to prevent this, he adds a mathematical placeholder, lambda.
A repulsive force to hold the universe static and stable.
But then, in 1929, Edwin Hubble publishes his observation that the galaxies appear to be receding.
The universe is seemingly not static.
Exactly. So Einstein abandons lambda, allegedly calling it his biggest blunder, and accepts a dynamic cosmos.
But then, decades later, in the late 1990s, cosmologists discover the recession appears to be accelerating.
Right. So they resurrect Einstein's lambda, inject it back into the equations, and rename it dark energy.
A mysterious fluid pushing space apart.
But under mode identity theory, Einstein's blunder wasn't adding the constant to make a static universe.
His blunder was listening to Hubble and taking it out.
Yes, he was correct the first time purely through mathematical intuition. Lambda is not a mysterious, undetected dark energy fluid.
What is it then?
It is topologically protected geometry.
Yeah.
Specifically, lambda is the ground mode eigenvalue of the Mobius surface.
Okay, let's unpack that. Ground mode eigenvalue.
Think of a drumhead stretched over a snare drum. When you strike it, the membrane can vibrate in many different complex patterns or modes. The simplest, lowest frequency vibration, the fundamental tone where the entire drumhead moves up and down together, is the ground mode.
Okay, I can picture that.
Because the universe's surface is a twisted Mobius band curved inside a three-sphere, its lowest possible vibration has a specific, irreducible mathematical value.
And in this geometry, that value is what?
2 over r squared, where r is the radius of the universe.
2 over r squared. And because that value is a structural property of the drumhead itself, it cannot change unless the universe physically changes size.
Which it doesn't.
Right. So it never changes.
It never changes. It is the geometric baseline hum of the universe.
That is massive.
It really is. And it provides immediate clarity on recent panic in the cosmology community.
You're talking about DESI, right?
Yes, the Dark Energy Spectroscopic Instrument. They recently reported signals suggesting that dark energy might be evolving over time,
Right. The data hinted that dark energy might cross the phantom threshold,
where its equation of state drops below -1.
which is a terrifying concept for cosmologists. Because if dark energy gets stronger over time, it leads to the big rip scenario.
Right, where everything is just violently torn apart right down to the atoms.
Exactly. But MIT says this is impossible.
MIT demonstrates mathematically that this phantom crossing is a template artifact.
An artifact, like an error.
It's an illusion caused by using the wrong diagnostic machine. When you take the pure static phase clock data of MIT and force it through the mathematical template of the standard model misinterprets the curvature of the phase wave.
So it basically hallucinates an evolving dark energy.
Perfectly said. It hallucinates it. Mode identity theory proves the true equation of state never crosses that threshold. What evolves is our localized perspective as we ride the waltz clock, not the fundamental geometry.
Forensic engineering at its finest.
Exactly.
You don't assume the building is spontaneously generating new invisible forces. You check to see if your measuring tape is warped.
Right, you check your tools.
But if this static three-sphere model is the correct foundation, it needs to solve more than just dark energy. We have massive observational crises, what you could call fingerprints on the sky, that are just tearing modern astrophysics apart.
The most prominent of these being the Hubble tension.
Right. For you listening, the Hubble tension is arguably the biggest crisis in physics today. We have 2 incredibly precise ways to measure the Hubble constant, which dictates the rate at which we observe redshift.
Right.
The first method looks at the early universe. We measure the cosmic microwave background, the CMB, which is the afterglow of radiation left over from when atoms first formed.
And when we use the CMB, we get a Hubble constant of 67.4.
Right. But the second method looks at the late universe. We use local distance ladders. We measure the pulsation rates of Cepheid variable stars and supernovae in nearby galaxies.
And when we calculate the Hubble constant using this local data, we get a value of 73.
67.4 versus 73. Both of these methods have been rigorously checked, calibrated, scrubbed for errors. They are both mathematically sound.
Completely sound.
Yet they fundamentally disagree. Standard cosmology cannot explain how the universe shifted gears from 67.4 to 73. So how does a static geometry resolve a disagreement like this?
The resolution relies on phase field mechanics. The framework models the spatial domain of the universe as a 120-sided structure.
A 120-sided structure.
Yes. This is derived from the symmetry of the binary icosahedral group, which represents the maximum discrete resolution of the S3 space.
Okay.
On this 120-domain standing wave, stable measurement positions occur exclusively at Fibonacci numbers.
Wait, Fibonacci numbers?
Yes.
The sequence where each number is the sum of the 2 before it. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55.
That's the one.
Why on earth does the universe care about a math sequence famous for describing pine cones and seashells?
Because of the golden ratio. The ratio between consecutive Fibonacci numbers approaches the golden ratio.
Right.
And in mathematics, the golden ratio is the most irrational number. It is the hardest number to approximate using simple fractions.
Okay, but what does that mean for a wave?
In the context of a resonating wave, it means a Fibonacci position is maximally resistant to resonant perturbation. It is the quietest, most stable place to sit on the wave.
Oh, wow.
And the Hubble constant naturally sits at the Fibonacci well of 34 over 120.
So the cosmic microwave background, which is a global measurement taking in the entire sky, is measuring the baseline standing wave at that exact well, 34 over 120.
Exactly, and that yields the 67.4 value.
But the local distance ladder measurements are not global.
No, they're not.
Yes.
They're calibrated inside massive flat curve disk galaxies. Our Milky Way, Andromeda, the galaxies hosting the supernovae we observe,
Right.
being deeply embedded inside a massive rotating galactic structure, physically shifts your phase position on the field.
It physically shifts it.
Yes, it triggers a discrete shift of exactly one bosonic step on the 120 grid.
What is a bosonic step?
It is a shift of 2 over 120. The localized observer inside the galaxy is no longer measuring the baseline wave from the 34 over 120 position. The local galactic environment has shifted their reference frame to 36 over 120.
Let me make sure I grasp the scale of this. You're saying that simply shifting the observation point from 34 to 36 out of 120 completely accounts for the difference between 67.4 and 73.
It is an exact mathematical translation. When you calculate the logarithmic slope of the phase operator at that specific Fibonacci well, a shift of 2 steps on the 120 grid translates into an 8.4% increase in the observed rate.
Wait.
Take the CMB baseline value of 67.4. Increase it by exactly 8.4%.
You get 73.
You get 73. Both measurements are perfect. Both measurements are capturing the exact same standing wave.
That is incredible.
The tension is entirely a product of treating the universe as a homogeneous structure. Rather than recognizing that local structural geometry alters the phase reading, the tension vanishes completely.
That fundamentally changes how we view our telescopes. We aren't looking at a universe breaking its own rules. We are just failing to account for the thickness of the glass we're looking through.
Beautifully put.
Does this phase shifting also explain the crisis with the James Webb Space Telescope?
It absolutely does. The JWST was designed to peer further back in time than any telescope in history, looking at the very first galaxies forming.
Right. And standard cosmological models predict that at that early stage, we should only see small, messy proto-galaxies.
Because it takes billions of years for dark matter halos to accumulate enough gravity to pull together massive galaxies.
But JWST is finding absolute monsters. Galaxies as massive as the Milky Way, fully formed, sitting at wedgeshifts where the universe was supposedly only a few 100 million years old.
The community is in panic mode.
Yeah, because there simply wasn't enough time for standard gravity to build those structures.
Well, in standard physics, gravitational acceleration is treated as a universal constant across time. But in MIT, the acceleration scale that dictates how galaxies rotate and form, which is known in modified gravity circles as MOND acceleration, or a zero.
Right, a zero.
That scale is an edge mode on that same 120 domain standing wave. Because a zero and the Hubble rate, h, exist on the exact same temporal edge of the geometry, they are structurally locked together by their Fibonacci well positions.
Okay, so what are their walls?
A0 sits at the 13 well, h sits at the 34 well.
Meaning, if one changes relative to the observer's phase, the other must change proportionally.
Exactly. As we look back to higher redshifts, we're observing earlier phases of the standing wave where h was significantly higher.
And because they are locked?
Because the two values are structurally locked, the baseline acceleration of gravity, a zero, must have been proportionally higher as well.
So how much stronger was it?
When you calculate the math for a galaxy at redshift 10, the baseline gravitational acceleration was effectively 20 times stronger than it is in our local universe today.
20 times stronger.
Yes.
I mean, if gravity's pulling a massive cloud of gas and dust together 20 times harder, then of course you don't need billions of years to form a massive galaxy.
Exactly. They would collapse and ignite into structured galaxies incredibly fast.
So JWST isn't breaking cosmology. It's just confirming that gravity was fundamentally tighter in the early phase of the wave.
We see this exact same geometric inevitability when we look at the anomalies in the cosmic microwave background.
Oh, you're talking about the axis of evil.
Yes, the rather melodramatic name cosmologists gave to a series of persistent anomalies in the CMB data.
Right.
For decades, satellites like COPE, WMAP, and Planck have mapped the temperature fluctuations of the microwave background,
Yeah.
and they found bizarre patterns at the largest observable scales.
Because the standard model assumes the universe should look basically the same in all directions. Just random quantum noise smeared across the sky.
But the sky isn't random. The quadrupole, which represents the largest hot and cold spots in the universe, is missing a massive amount of power. It's unusually weak.
And worse, the multipoles seem to align along a massive singular axis cutting across the universe.
Right, and standard cosmology has largely tried to sweep this under the rug.
They call it cosmic variance, right?
Yeah, cosmic variance, which is just a polite way of saying a statistical fluke we can't explain.
But MIT has an explanation.
It is not a statistical fluke.
Mm.
Under mode identity theory, the axis of evil is the literal, physical projection of the Mobius band twisting across the sky.
Wow.
Think about the anti-periodic boundary condition we discussed earlier. A wave takes 2 laps to return to its original state. This specific topological twist naturally suppresses certain even-numbered modes of vibration.
So it perfectly suppresses the quadrupole moment of the CMB.
The geometry physically restricts that specific vibrational frequency from forming.
That is wild.
Furthermore, the preferred alignment, the axis everything seems to revolve around, is the exact normal axis of the Mobius twist itself.
We're looking at the seams of the universe's envelope.
And it goes even deeper. If you place the observer, our solar system, at a geodesic distance of roughly 2.1 gigaparsecs from the center of this geometric domain, the math aligns perfectly.
2.1 gigaparsec.
Yes, that single geometric address simultaneously solves the parity asymmetry magnitude, the exact alignment angle, and the quadrupole suppression.
4 massive anomalies resolved just by acknowledging the universe has a shape, and we are looking at the shadows it casts.
Exactly.
Okay, we've established how the static 3-sphere geometry completely dictates the massive scales of the cosmos. Galaxies, the CMB, the observable redshift.
Right.
But I want to shift our focus entirely. Let's look at the absolute smallest scales of reality.
Okay, let's zoom in.
We are going down past the cells, past the atoms, into the particle colliders. How can a static 3-sphere dictate the specific inventory of subatomic particles?
To bridge that gap, we return to the fundamental spatial domain, the S3 space, modulated by the binary icosahedral group.
The 120-sided die.
Yes. The icosahedron is a highly symmetric geometric shape, and like any geometric solid, it is defined by its faces, its edges, and its vertices.
Right.
In the mathematics of group theory, the symmetries of this icosahedral structure are governed by the prime numbers that divide 120.
Which are?
2, 3, and 5.
Mm.
These prime numbers act as mathematical stabilizers. They isolate specific vibrational modes on the standing wave.
So the geometry is acting like a filter. How do the faces, governed by the prime number 3, dictate particles?
The faces of the structure have threefold symmetry. When the mathematical representation of the energy wave is restricted to these faces, it splits into 2 distinct topological categories, singlets and triplets.
Oh, singlets and triplets. Are we talking about the strong nuclear force, like color charge?
Precisely. In the standard model of particle physics, quarks, the particles that make up protons and neutrons, come in 3 colors: red, green, and blue.
So they are color triplets.
Yes. Leptons, on the other hand, like the electron, do not interact with the strong force. They are color neutral or singlets.
Okay.
The standard model simply observes this fact. MIT explains it. The threefold geometry of the faces literally dictates whether a localized wave of energy manifests as a lepton or a quark.
The geometry generates the color charge.
Yes.
That is profound. So the faces dictate quarks versus electrons. What about the edges?
The edges have a 4-fold symmetry in the double cover, which ties to the prime number 2. This enforces a strict binary restriction on the size of the domain the wave can occupy.
Binary restriction.
Half-integer representations are allowed to resonate across the full 120 domain. Integer representations are restricted to a halved 60 domain.
Let me translate that. Half-integer spin versus integer spin. You are talking about fermions versus bosons, matter versus forces.
Exactly. Fermions, matter particles, have half-integer spin. Bosons, force carriers like the photon or the gluon, have integer spin.
Right.
The edges of the geometry generate the fundamental spin statistics difference between the particles that make up the physical world and the particles that push them around.
Unbelievable. Faces give us quarks, edges give us matter versus forces. That leaves the vertices, the points of the die.
The vertices have a 5-fold symmetry. When this 5-fold geometry interacts with the overarching Mobius twist of the universe, it generates the electroweak interface.
Okay, what does that mean in practical terms?
It dictates weak isospin. This is the mechanism that separates up-type quarks from down-type quarks and dictates why neutrinos behave differently from electrons under the weak nuclear force.
This completely demystifies the particle zoo. I mean, the universe isn't a random soup of ingredients where God just threw in some quarks, an electron, and a photon for good measure.
No, not at all.
It is a rigid 120-sided structure, and a wave of energy has no choice but to conform to the faces, edges, and vertices of that shape. Form before function.
And because it is rigid, it doesn't just categorize the particles, it calculates their exact properties. The most stunning example is the fine structure constant, denoted by alpha.
The magic number, 1 over 137.
Yes.
Richard Feynman, one of the greatest physicists of the 20th century, said this number was a damn mystery, a magic number that comes to us with no understanding by man.
It defines the strength of the electromagnetic interaction.
Right, if it were even slightly different, stars wouldn't burn, carbon wouldn't form, and we wouldn't exist.
In standard physics, alpha is a dimensionless parameter. You can't derive it from simpler principles, you just have to measure it in a lab and plug it into your equations.
But MIT?
Mode identity theory derives it natively from the geometry, using 3 strict structural modifications to the phase scaling law.
Okay, walk me through those 3 modifications. How do we get 1 over 137 out of a 120-sided shape?
First, we are calculating the coupling of the photon. The photon is a force carrier. It is a boson. Therefore, as we established with the edges, it must evaluate on the restricted bosonic 60 grid, not the full 120 grid.
Okay, that makes sense.
Second, what does the photon do? It couples matter to matter. It is the messenger between electrons.
Right.
Therefore, the amplitude of the photon must evaluate at the exact Fibonacci well that governs matter dynamics, the 13th well.
Okay, we have the 13th well on the 60 grid. What is the third rule?
The third rule concerns the hierarchy scale. Because alpha is a dimensionless coupling constant, a pure ratio, rather than a physical measurement like mass or length, it cannot take a full integer power of the cosmic hierarchy scale.
So what does it take?
It takes exactly one single discrete grid step. This means the exponent applied to the hierarchy is exactly 1 over 60.
So the formula is the phase amplitude at the 13th well of a 60 grid, multiplied by the cosmic hierarchy scale taken to the negative 1 over 60th power.
When you calculate that exact geometric intersection, the result is approximately 0.000733.
Which is roughly 1 over 136.4.
It lands within 0.5% of the experimentally measured value of the fine structure constant simply by reading the geometry of the grid.
I have to play devil's advocate here.
Please do.
A skeptic, especially a string theorist who is used to playing with mathematical landscapes, might look at this and say, look, you have a bunch of numbers, 60, 120, 13, 34. If you multiply, divide, and exponentiate them in enough different combinations, eventually you'll land near 1 over 137.
Sure.
It's just numerology. It's Texas sharpshooting.
That is the exact critique the author anticipated. To prove it isn't numerology, the author ran a rigorous uniqueness scan.
A uniqueness scan.
Yes. They tested every single possible combination of phase wells and fractional exponents across the grid.
And what did they find?
If you ignore the topological rules, yes, you can find a few random mathematical combinations that land near the number, but when you apply the strict structural checklist, it must use a bosonic grid. It must evaluate at the matter. Well, it must use the specific icosahedral exponent. The MIT formula is the only valid algebraic path that survives.
Wow.
It passes a 6-point structural uniqueness test. It is not a coincidence. It is a topological inevitability.
And the predictive power goes beyond the fine structure constant, right?
Yeah.
This framework actually predicts the masses of the particles.
Yes, the theory provides a unified mass formula. It generates 24 mass entries. It does this by pulling directly from the vacuum energy floor, which is mathematically the 4th root of the cosmological constant, lambda.
Okay.
It takes that baseline energy, multiplies it by the phase position, the hierarchy distance, and a topological invariant known as Reidemeister torsion.
Reidemeister torsion. We need an analogy for this. It sounds like a medieval torture device.
It kind of does. Think of it as a measure of how a space twists globally. Local curvature is like a bump in a rug.
Okay.
Reidemeister torsion is about the global winding, like the tension stored in a twisted rubber band. It encodes the fine structure of the manifold.
I see.
What is critical here is that on this specific S3 quotient space, the mathematics dictate there are exactly 3 isolated flat connections.
3 isolated flat connections.
There are 3 distinct ways to configure that topological tension without adding extra localized energy.
Wait, three isolated configurations. Does this explain the generations of matter?
Yes.
Because in the standard model, we have the electron, but we also have the muon and the tau.
Right.
They're exactly identical to the electron in every way, same charge, same spin, but they are massive and unstable. It's like having three identical cars, but one weighs a ton, one weighs 50 tons, and one weighs 1,000 tons.
Exactly. Particle physicists have spent decades wondering who ordered the muon and the tau.
MIT says there are three generations of matter because the shape of the universe has exactly three topological vacua.
There is no continuous smooth bridge between them. You snap into the first flat connection, you get an electron. You snap into the second, you get a muon.
That is so clean.
And when the formula is run across these connections, 10 of the predicted mass entries map directly to the 12 standard model fermions.
How close are the values?
9 of them land within a factor of 3 of the experimental value, and the masses of the electron, the up quark, and the muon land within 6% of the actual measured mass.
The geometry is literally predicting the mass of the building blocks of reality.
It really is.
Let's take a breath, because we need to bridge the two halves of this deep dive. We have the discrete quantum particles, the faces and edges of our 120-sided die.
Right.
And we have the continuous macroscopic space, the static three-sphere, and the standing wave. How do these two totally different mathematical regimes talk to each other?
They talk to each other through gravity.
Gravity, the oldest, most obvious force we experience, and the one force that stubbornly refuses to fit into quantum mechanics.
Yep, the big problem child of physics.
We can quantize electromagnetism, we can quantize the nuclear forces, but quantum gravity has been a brick wall for a century.
Mode identity theory shows us exactly why that wall exists. In standard physics, Newton's gravitational constant, g, is treated as a fundamental constant of nature.
It's just an inherent property of mass pulling on mass.
But in MIT, g is not a fundamental force constant, it is an exchange rate.
An exchange rate? Like banking.
Exactly like banking. Imagine general relativity, the continuous macroscopic space,
Yeah.
operates purely in dollars.
Okay.
Quantum mechanics, the discrete particle grid, operates purely in euros. Gravity is the bank teller sitting at the interface.
So it's translating.
To translate the 2D discrete Mobius surface curvature into 3D continuous spatial dynamics, you need a mathematical bridge. That bridge is provided by the Gauss equation.
And what is the exchange rate the teller charges?
The ratio is exactly 3/2, and this ratio is profoundly geometric. Think back to the stabilizers of the icosahedron.
The prime numbers?
The faces have order 3, the edges have order 2. The ratio 3/2 is the intrinsic mathematical cost of carrying topological information across that geometric interface.
So G is just the dictionary entry translating 2D topological curvature into 3D physical energy.
That's all it is.
If gravity is just the bank teller translating between two different currencies, then no wonder we can't quantize it.
Exactly. The century-long quest for quantum gravity failed because it fundamentally misunderstood the job of gravity.
Because quantum mechanics demands that everything be discrete and choppy.
Right. And general relativity demands that space be smooth and continuous. Standard physicists have tried to force gravity to be either entirely discrete or entirely continuous.
But it's both. Or rather, it's the bridge between them.
Gravity bridges two fundamentally incompatible types of mathematical reality. You cannot quantize gravity without discretizing the 3D space.
And if you do that,
you destroy the continuous curvature that creates the cosmological constant. You destroy lambda.
oh wow.
Conversely, you cannot make the quantum side continuous without destroying the discrete 120 domain that gives us the particles.
So gravity resists quantization because its entire geometric purpose is to be the interface.
You are asking the bank teller to become the currency.
That is an incredibly elegant solution to the biggest headache in physics. But, talking about gravity inevitably leads us to the extreme edge of the map.
Black holes.
Exactly. In standard physics, a black hole is usually described as a singularity, an infinitely dense point where space-time stretches down an infinitely deep gravitational well, ripping the laws of physics apart.
Right.
If space is a static three-sphere and it isn't stretching, what exactly is a black hole?
It is not a bottomless pit. It is a topological node. Specifically, the theory defines it as a double zero.
A double zero. Break down what is hitting zero.
In the scaling law that defines our reality,
Yeah.
two distinct mathematical factors define an observer's perspective. The first is the sampling amplitude, which tells you your position on the standing wave. The second is the local scale hierarchy, which provides the separation between the microscopic Planck scale and the macroscopic cosmic scale.
And at the event horizon?
At the event horizon of a black hole, Both of these factors hit zero simultaneously.
Let's take the first zero. The sampling amplitude hits zero. What does that mean physically?
The spatial mode hits a node on the wave. The phase position reaches the absolute boundary of the domain. At that specific coordinate, the wave simply has zero amplitude.
Okay, and the second is zero.
The collapse of the local scale hierarchy. The phase gradient shrinks to nothing. This means the mathematical distance between the tiny quantum scale and the massive cosmic scale ceases to exist.
I want to push back here, because if you fall into a black hole, you don't just cease to exist mathematically, you are made of mass. What happens to the information? What happens to the star that collapsed to form it?
That's a great question.
I want to go back to the guitar string analogy. If I press my finger exactly on the halfway point of a vibrating guitar string, I create a harmonic node. The string at that exact millimeter doesn't move up or down.
Right, the amplitude is zero.
But the string itself didn't vanish? The brass and steel are still there, the wave is still traveling through it. It's just silent at my finger.
That is a perfect physical representation of the double zero. In a black hole, the matter and information are not destroyed in a singularity.
So it is still there?
The wave persists. The topology of the universe holds firm. But the localized observer goes silent. You simply cannot mathematically sample the wave at that specific topological coordinate.
So this completely resolves the famous black hole information paradox.
It does.
Stephen Hawking and Leonard Susskind argued for decades about whether black holes delete quantum information from the universe. Physicists invented insane concepts like firewalls and holographic projections at the event horizon just to save the data.
MIT says we don't need any of that. The information isn't deleted, it's just unsampled.
That is incredible.
And the geometry actually accounts for Stephen Hawking's greatest discovery, Hawking radiation.
Because a black hole isn't perfectly black, right? It emits a faint glow of thermal radiation.
Exactly. In MIT, because the horizon is a double zero node, the amplitude is zero. But the first derivative of the wave, the curvature of the amplitude, survives the node.
So it leaks out.
It mathematically leaks through the 0 point. Hawking radiation is simply the residual sampling at the first non-vanishing order of the double zero. It is not some exotic quantum pair production trick happening at the edge of Rip spacetime. It is the geometric necessity of a standing wave passing through a topological node.
Every piece of this theory fits together like a jigsaw puzzle. But we are arriving at the climax of this deep dive.
The curvature duality.
Yes. And this is where the physics, the math, and the philosophy merge in a way that is almost terrifying.
It is the deepest mathematical truth revealed by mode identity theory. It connects the physical existence of matter to the most profound unsolved problem in pure mathematics, the Riemann hypothesis.
The Riemann hypothesis. For you listening, this is the holy grail of math. It deals with the distribution of prime numbers.
Right.
The Riemann zeta function is a complex mathematical landscape, and the hypothesis states that all the non-trivial zeros of this function lie on one single, perfectly straight line. If someone can prove it, they will unlock the deepest structural secrets of arithmetic.
And for decades, mathematicians and physicists have tried to prove it using an approach called spectral geometry.
How does that work?
The idea is to find a physical space, a specific geometric manifold, where the vibrations or eigenvalues of that space correspond exactly to the Riemann zeros. If you can find a drum that naturally hums the exact frequencies of the prime numbers, the physics proves the mathematics.
But we just spent an hour establishing that the universe is a purely geometric three-sphere drum vibrating with prime number stabilizers. 2, 3, 5. So does the S3 geometry of mode identity theory prove the Riemann hypothesis?
It does the exact opposite. It proves mathematically that the Riemann zeros are structurally inaccessible on this manifold.
Wait, it blocks them. Why would the geometry mirror the primes but block the zeros?
To understand the blockage, we have to look at another million-dollar physics problem, the Yang-Mills mass gap.
Okay, the mass gap.
In the year 2000, the Clay Mathematics Institute offered $1 million to anyone who could prove exactly why the strong nuclear force has a mass gap. Why do particles have mass instead of just zipping around at the speed of light like massless photons?
Why are quarks confined inside protons, basically?
Right. And mode identity theory provides the mechanism.
For curvature.
Yes. On the static S3 space, the Ricci curvature is inherently positive. It has a baseline value of 2 over r squared. According to a mathematical theorem called the Weizenbuck identity, this positive curvature creates a mandatory universal floor for the gauge fluctuations.
A floor, meaning the energy of the vibrations literally cannot drop to zero.
Exactly. In flat space, waves can have zero energy. In positively curved space, the curvature adds a mandatory baseline energy.
So it bumps everything up.
This geometric floor guarantees the mass gap. It is the reason particles have mass. It is the reason matter can coalesce. It is the reason we exist.
Positive curvature creates mass. That is a massive victory for the theory. But where do the Riemann zeros come into this?
Here's the devastating twist. This exact same positive curvature, the 2 over r squared, that gives us the mass gap, mathematically ruins the spectral eigenvalues.
Ruins them.
It shifts the scalar Laplacian eigenvalues so they are no longer perfect squares. This geometric shift creates what is known in mathematics as an infinite Pochhammer tower at the spectral zero.
Okay, a Pochhammer tower, that sounds incredibly dense. Give me a way to visualize this.
A Pochhammer symbol in math denotes a rising factorial, a sequence that multiplies infinitely. Imagine you have a beautifully tuned piano and the keys represent the Riemann zeros.
Okay.
If you play those keys in a perfectly flat zero curvature room, you hear the crisp, perfect notes of the prime numbers. You can map them perfectly.
Because there's no distortion.
Exactly. But the room we live in, the S3 universe, is positively curved. That curvature warps the wood of the piano. When you strike a key, it doesn't just play a single note. It creates an infinite cascading echo.
Wow.
That infinite echo is the Pochhammer tower. It smears the math out. It mathematically blocks general spectral factorization. The curvature structurally shields the Riemann zeros.
So you can't isolate them.
You cannot isolate them. You cannot use this physical space to prove the Riemann hypothesis.
Let me just synthesize the magnitude of this. The universe is built on this beautiful, rigid, 120-sided prime number geometry. It is a perfect physical mirror of arithmetic, but it forces an ultimate cosmic choice.
It is a zero-sum game between existence and omniscience.
You can have flat space. If you have flat space with zero curvature, the Pochhammer tower vanishes. The echoes stop. You have perfect mathematical transparency to the Riemann zeros. You could read the absolute deepest secrets of the prime numbers. But without that positive curvature, you have no mass gap. Without the mass gap, you have no mass. No quarks, no atoms, no matter. There would be no observers to actually do the math.
Or you can have positive curvature. You get the mass gap. You get quarks, stars, planets, and life. You get observers capable of building telescopes and looking up at the night sky.
But the exact curvature that allows you the physical mass to exist structurally shields the deepest secrets of the mathematics from your eyes. Mass and mathematical transparency are in structural opposition. The curvature that realizes one forbids the other. The universe chose matter. We exist, but we are mathematically blinded by the very mass that makes us. You can't use a mirror to look behind the mirror.
The field equations of Einstein, heavily modified over a century, do a decent job describing the behavior of the universe. But mode identity theory describes the structure. Space leaps, the surface follows, and the geometric floor hums.
We have covered an astonishing amount of ground today. We have forensically stripped the universe down to the studs, and we did not find a stretching cosmos filled with dark fluid.
No, we found geometry.
Exactly. For you listening, let's summarize the staggering scope of this blueprint. We are the universe taking a localized reading of a static, beautifully complex standing wave.
Dark energy, lambda, is not a fluid. It is the structural hum of the Mobius boundary.
Redshift is just the ticking of the cosmic waltz clock.
Gravity is not a force. It is the 3/2 exchange rate between discrete quantum topology and continuous cosmic space.
And the very curvature that gives us the mass to exist hides the ultimate mathematical truth from our eyes.
It is the ultimate realization of Plato's philosophy. The shape of the room dictates the music.
I want to leave you with a lingering question to ponder. A thought that builds on everything we've torn down and rebuilt today. If every event, every particle, every physical force, and every galaxy is just the standing wave resolving at our specific localized observer position, what happens to the nature of reality when the observer fully understands the shape of the wave they are sampling? When the universe, through us, finally sees its own geometric reflection clearly, does the octave finally complete?